Okay, hey folks. I think some of you were in the workshop yesterday, so I'll try and make it different than that content as much as possible. So this is kind of the higher level view of what we've achieved with chiseled containers. And just if you, so we did have a workshop yesterday, and there was a bunch of content that we went over. So feel free to grab that. I can bring it up at the end too. So it's a GitHub repo with a bunch of instructions on what to do. It's yeah, quite .NET oriented, but it definitely is a use case of chiseled for sure. So I shared this yesterday as well. So this is my kind of like provocative premise for this whole thing, which is we've been doing containers for like 10, 15 years now. And the basic premise of this talk and of all of this work is that the general purpose container images are not our future, that like super stripped down ones that are purpose built and bespoke are our future. And chiseled images absolutely satisfy this premise. So so for .NET, we have all these base images that my team ships. And so on the left, we have all the base image, or a set of the base image options of the Ubuntu ones that we have available. And the jammy one on the left is just like regular Ubuntu. So if you do docker pull ubuntu jammy, this is the exact same thing as that, except with a bunch of .NET stuff added on. And actually, this is for an app. So this would be an app that sat on top of ubuntu.net, and that's so you that whole thing would be 86 megabytes. And then we have some other options with chiseled, brings you down to 48. And so what this is, what that's assuming is it's our JIT runtime. So it's like, fairly decent sized runtime, the app. And then if we go all the way to the right, we have this native AOT thing, which is a smaller runtime that's entirely oriented on the app already having been statically compiled, no JIT. And then we use chiseled, and we get down to 8 megabyte compressed. So basically, the value prop here is, if you're cool with how things have always worked, then and you don't want to spend any extra effort, you can continue doing that thing on the far left. It's totally not going away. If you're someone who cares about, the highest performance available and the smallest footprint with respect to, the components you're bringing on, CVE, compliance, blah, 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 then you can invest some extra effort. And it's like remove 90% of the size of your container image. So we've got that whole stair step sort of set of options. And with each step, you kind of only have to do a small thing. There's no actual chasm across this, so that's cool. Yeah, so the announcements are, we've been working on these Ubuntu chiseled containers with Canonical. Those are now GA. They're available for all the supported .NET versions, and the last .NET version is GA next week or so. So the timing is really excellent. Okay, so I thought I would give a couple of slides that give a sense of what the .NET ecosystem is all about. I actually stole these slides from our conference from next week. Hope my management is not unhappy with that. And so people might wonder, like, how big is this .NET ecosystem anyway? So it's around 6 million monthly active users. So users here are developers. I work in developer division, so our customer is developers, not end users. And we've actually built a really great open source ecosystem. So that's what that 53,000 is. So we have people coming to our repositories like every single day, making PRs, some of them quite gigantic and impressive. And you can see that we've had, some momentum with our product. This is a slide that talks about like, we focus a ton on performance. And so Tech Empower is a third-party benchmark out in the industry. We totally don't own it or have any like specific relationship with them. JSON is like super focused on JSON responses. Fortunes is actually a larger one that even includes databases. And our team invests in improving on this thing every year. We think this is like a cloud-oriented benchmark. And then you can see there are other programming languages that do that do less well. Okay, so brief history of containers. This is again kind of part of the premise. So I think when we started with container land, basically containers were to a large degree like a one-to-one representation of what's shipped in the in the VM images, and so it was very much like not how do we take this operating system and make it purpose built for containers. That is absolutely not where we started. I mean, yeah, it's not. And there's like, if you look inside the container images, there's tons of stuff that doesn't specifically need to be there. And then over time, once containers move from like theory to practice, people realized that maybe this isn't quite what we wanted, and so performance and security concerns became more relevant. We also had new offerings in the industry, so Alpine was an example of that. Much later, we have ChainGuard. You know, they have their own kind of like they're absolutely on the purpose-built container first ecosystem plan. And around that same time, Google created this distroless thing, and that was very much like an outsider take on how do we create container images, but it was not built into, you know, Ubuntu or Debian or anything like that. You know, they use their Bazel tools to do that, and that didn't really take off because it was this very Google thing that if you had problems, you probably didn't have anyone to help you. So I think that was a huge problem. And then when we first started working with Canonical, obviously we had all of this context. And so the thing that was really interesting to us is we could create purpose-built container images. We could do very much do this, satisfy the goals that Google had with their distroless project, but they would be supported. Like in the case of .NET, like our customers have both Canonical and Microsoft supporting them with their with these container images. So they're absolutely an enterprise offering, and the feedback has been super good. And so when I think about you know, I'm a product manager on the .NET team. So when I think of the customer needs that we're satisfying, this is my list. It turned out to be C's and S's, not on purpose. And like when I talk to customers, this is absolutely the list of characteristics that they care about, all of them, and they yeah. Um, and our chiseled images are we're getting check marks on every single one of those. And as we were doing the project, these were totally the things that we were discussing and had in mind. Okay, so repeat of the slides from the workshop. So let's look at what this actually looks like. So these are our existing container images that we've been shipping. So, you know, again, so the Ubuntu Jammy image is 28 megabytes compressed, and then we build our product on that. The runtime depths layer is the one that might be a little bit less self-explanatory. So that is doesn't have any .NET in it. All it has is the dependencies that our product depends on above and beyond Ubuntu, above and beyond the operating system. So for every operating system we support, we have this runtime depths layer. So you can see it adds like 18 megabytes or something like that, if I'm doing the math correctly. And the other thing to realize is this is a rootful. This whole stack is rootful, so the user in all single one of these layers is root. And then so for prod, for apps, you're starting with 90 megabytes compressed. The SDK is a little bit less relevant because that's only used to build your app for a multi-stage build. And then we do chiseled, and then so we start to change the game quite a bit. So now that Ubuntu layer is 0, right? Because now we have a bespoke purpose built. This is the first actual layer, this runtime depths layer. And so now we've made that 5.6 megabytes. It's like, good God. Before, runtime depths was 46 megabytes. So that's basically, again, like a 90% reduction in size. And so we made a policy decision with these container images. We realized that effectively what we were building was compute appliances. And so we put a non-root user in these images in the runtime depths layer called app. Um, and it's set as that. So the images set that user. And so the whole chisel stack is non-root. You can opt out of that, but that's so we decided for like appliance computing that was the right thing. And then we have this other thing, native AOT, so we were able to strip this down even a bit further. So with native AOT, there are no additional layers because it's only ever self-contained compute. You don't rely on an additional runtime. When you build a native AOT binary, it's self-contained. It's like just like what you would expect from a Go binary. Has the runtime in it, every single thing that it needs beyond operating system dependencies. And so that thing is 4.8 megabytes. So it turns out we live in a world where people speak different languages and have like different calendars and time zones and all this kind of stuff. And a lot of apps rely on this. And so one piece of friction when we build this like super stripped down stuff, people need ICU and TZ data and that kind of thing. And so for this project, we decided we would build this extra thing. So it actually kind of sits on top of that one now that I think about it. But so it contains the globalization stuff, and you can see how thick and chunky this globalization stuff is, because literally the only thing above and beyond that image is ICU and TZ data. I think those are the only additional things in there. So that's a ton of space. And so that's an app that if I get time, I'll demo. We should quickly move to demos. And so that app is native AOT app built on that thing on the left. And so that's container images, 18 megabytes. So that's great. Okay, we came to demos. I think we'll stay in demo land now. Okay, so what I wanted to show you was just a few demos, and we have basically just 10 minutes. Let's see if this. It's on the bottom part. Okay, you can help me with that. That would be awesome. Yep. I don't have those kind of skills. Thank you. Perfect. Okay. Okay, so what I was going to show you is, yeah. Okay. Yeah, super bizarre. Okay, so I'm going to have to make this a bit bigger. Okay, so I'm going to show you a couple demos. Slightly bizarre. Okay, so this is a console app. I think this. Okay, let's do this too. Okay. Definitely not an expert on this. Okay, so what we're going to do, let's make this easy. I'm just going to go back in my history. So we have this OCI publishing solution. So OCI is basically just spec container images. And so I have this app. And so using this command with our tool chain, I can publish it to a container image. And so that it's already done. And so what it's saying is I built this code for you, and I put it into a container image based on this base image from the registry. So this is like one of those first images that had all the big sizes. So it's called .NET app. So it's 193 megabytes. So that's kind of somewhat aligning with those sizes. So that's not making us like super happy. So so we're going to make this a self-contained app, and I'm going to use this stuff called trimming, which basically says make this really small, publish trimming equals true. And I'm going to use this super cool feature that I absolutely love, container family equals jammy chiseled. So basically what I'm doing is, this is a JIT runtime app. Thank you so much. save me. Yeah, I'm good at spelling mistakes. So this is on the JIT runtime side. We're not doing the native AOT thing. And so, I changed a couple settings. And this app is quite simple. For more complicated apps, I might actually have to do a little bit of extra work. And so now, with this previous one, I was basing it on the runtime image. For this one, it's based on runtime depth. So I'm bringing my runtime with me, and I trimmed all the things about the runtime that I didn't need. And so now we got that down to 33 megabytes. So that's pretty awesome. Just one thing to show you. If we had not used chiseled, but still used Ubuntu, so now we're on the non-chiseled Ubuntu things, but we use trimming just to give you a sense of the value. So trimming, so the app now is the same. The thing that chiseled is giving, we're dropping from 140 megabytes to 33. Just by using these command line switches. So the last thing I want to show you on this is this demo. So what I'm doing is the exact same thing. I'll start this because it's going to take a little bit. So so we're trimming the app. Container family is Jammy chiseled. I'm able to set container repository to richlander/.NET app. The container registry I want to use is Docker.io. And then the cool thing is, in addition to that, so this is an x64 Ubuntu machine. And I decided, I want to cross compile. Usually it's the other way around. Usually an ARM64 machine and trying to deploy to an x64 cloud, but whatever. It's all the same. So then what I want to do is grab this thing, and now I'm back on my MacBook, and I'm going to run this and download that image locally. And I had some of the underlying stuff. And so I just built that on my x64 Linux machine in Seattle, actually. Pushed it to Docker Hub, and then I was able to pull this machine down, and it was the correct image type. So if I was to go Docker inspect richlander/.NET app, and then grep. I mean, this is obvious. This is going to work. It's an ARM64 image type. Was there a question that someone was about to ask? Oh, I thought I heard. Oh,
the 33 meg, is that the layer of the .NET app separate from the underlying chiseled sort of runtime, or was that the whole thing?
Sorry, where? Just a sec. Where did the? Okay. Yeah. Yes. Oh, sorry. Now I remember. Yes, you're saying. When I typed, that's the wrong window. That's the whole thing. So when Docker, you can see I'm confusing myself. Yeah, sorry. You're talking about this 33 megabytes. Apologies. Yes, that is the entirety of the container image, and that's when Docker reports these numbers to you. Those are uncompressed numbers. That's uncompressed.
We're chiseling a lot more than I thought.
Yes, yeah, unless there's a bug in my demo. No, the chiseling thing is literally dramatic. It's quite dramatic. I'm very, very bullish about it. Okay, so let's see if I can make a native AOT demo work in the time I have left. So I did that in a separate. Okay, so this one, let's see. Okay, let's start with so I'm just going to done it publish. Oh, good Lord. I don't know why this, I know what that was. What happens a lot is I use Docker images as well, and then they make the bin directories owned by root, which is super annoying. And then so I have to blow these directories away. There. Okay, so now we're going to do native AOT. And this takes a little bit longer. So now we're in the generating native code stage. So what this is doing, so our compiler, we actually use our JIT compiler offline to compile native code. We then obviously grab that stream of bytes, and then we put it into like like an SO file or a lib file or .a file, whatever it is, and then we use Clang linker to bring it all together. Oh, excellent question. Yeah, I apologize for how small this is. Let's make it a little bit bigger. So we yeah, so we have these project files. They're XML, and so you can either specify the properties on the command line, or you can just encode them into this project file so that you don't have to type it all the time. So this says publish AOT equals true, and that also means trimming. And then also we made the decision for our AOT apps to turn on invariant globalization. So we have all these string APIs for sorting, all of these globalization APIs. And so they either do an invariant thing or they throw when this invariant globalization is set to true. That means that the product doesn't have any dependency on ICU. So we're able to shed that and still have a product that works in a coherent way. And so this one is a much larger app because it's depending on our web stack and also our JSON stack. So this one is 60 megabytes. And so what was the other thing I wanted to show? Because that was with Jammy Chiseled. Right. Oh, right. And then, so what I'm going to do with this one, yeah, this is the awesome demo. So let's see if I can make all this work. Just change one thing and see if we can do the same thing as before. So what I'm doing now is with the first time I did this, I was relying on Clang and .NET on my machine. What I've done now is we have an SDK Docker image that has .NET Clang inside of it. I've volume mounted my source code in there. I've also volume mounted my Docker credentials into there. And I am building the app, and I'm also going to push to Docker Hub. In addition to that, I'm relying on cross-compiling Clang tools to build an ARM64 native binary on my x64 machine, and I'm pushing that off to Docker Hub. So that just happened. And let's go back to my MacBook. I think that's this one. I don't think I actually pushed this to this machine. So this will be the last demo. Docker run. And so this is a web app, as I said. Yeah, this should work. Yeah, I didn't pull this one locally. Before. And okay, so the app started. I could have done actually. Let's just do that to make this simple. I'm going to start this disconnected, or yeah, cool. And then I can. This has a couple endpoints on it. Curl HTTP localhost 8000 slash. So it has a health Z. If it has a health Z endpoint. So if you're familiar with Containerland. That's its health check. So it's awesome. It's healthy. And then it actually has a thing. The actual thing releases so what it does is this endpoint looks at a bunch of JSON files that we publish for each one of our releases. If I was doing this on Linux, I'd be able to run JQ. But I don't think I have JQ installed on my MacBook. Yeah, this app is actually a little, oh, cool, I do. This app is a little bit slow. It has nothing to do with native AOT or .NET. So what it's doing is we publish all these JSON files about our product, and about every single release and what the CVEs were in them. And so then it's generating JSON, which is it's telling you for each major version of the product, when it last shipped, what were the CVEs that were in that product so that you should know about it. It tells you how many days ago that release came out. And so it gives you an idea if you were like a compliance person, if you should be worried if you haven't updated. Is all based on public information there. And so it's just, showing that in a small envelope. And let's just see how big this is. And then this will basically be the end of the talk. This app, oh yeah, Richlander. So this was 52 megabytes, uncompressed. Yeah, and yeah, so that's what the app does, and yeah, it's awesome. Yes.
Can you custom the box?
Is there any sort of standard integration between .NET and things like Prometheus or other kind of
yes,
observability, tracing, profiling?
Yes. So amazing question. So we so .NET has a couple of things. One is we have open telemetry libraries for basically everything. So yeah, whatever you would do with open telemetry, we export spans and all those sorts of things. In addition to that, we have a tool and also a container image called .NET Monitor. What it does is it has a web server in it that over a Unix domain socket, it can then talk to a running app, and it can get privileged information from that.
Any running .NET app.
Any running .NET app, and then it's
including AOT.
Yeah, and it's this .NET Monitor thing is it exposes. It is a web server, and it exposes prom format data that is streaming out. So yeah, we totally do the Prometheus thing, and then you can hook up Grafana to .NET Monitor, and then you can do the whole Grafana Prometheus thingy and get all the data that you would want. And you can also expose custom. You can expose custom events as well. When .NET exposes like a dozen or two, I have no idea, but about a dozen of our own events that come through the Prometheus thing. It's pretty cool. I've used it.
And that's just standard effectively. You don't have to have coordinated too closely between that service and your app.
Right. You just need to .NET Monitor is something you opt into. So this yes, well, we're basically done. Yeah, you just have to do a couple things to say I want to do this. But it's not particularly special.
And you opt in at runtime or you opt in at build time?
You opt in at runtime. There's no change you need to make to your app. Yeah, there's no extra code.
You can just bind it to a running app.
Yeah, totally. With this a little bit goes to the conversation you and I were having earlier. So the way .NET Monitor works, and I assume it's the same with other ecosystems, we ship .NET Monitor as an image. So you would typically make it a sidecar, and it would be in pod. If you're a special person, you can then make it a daemon set. The only problem with a daemon set is you lose the kind of one-to-one Prometheus streaming scenario, because with Prometheus, it would talk to .NET Monitor, but it has no idea which app it wants. So yeah, the daemon set doesn't work super well. The other thing I should just mention about this JSON app that I showed you, one thing we did in our ecosystem is, like, since .NET is a JIT runtime, there's a lot of scenarios that use reflection, because reflection is an awesome capability. You can walk up to something and ask what methods and properties it has, which is super great for serialization. So for native AOT, that's less good. So we built a whole source generating system So you can basically, source generators are basically programs that run in the compiler. And so it can then, this program can say, what are all the properties you have? And then that program can then do code gen that is hard bound to the actual shape of the types that are doing serialization. So that's how that app is working. It doesn't actually do reflection. It has hardbound code to enable JSON serialization and deserialization to work. So just FYI. That's it.